Okay, talking about the gas laws. First off, there's three main gas laws. You have Boyle's law, you have Charles' law, and Gay-Lussac's law, and we'll talk about each one separately in a second here. But essentially, you could come up with an equation, or there is an equation for each one of these laws, and you could memorize the equation for each one if you wanted, and go about it that way to solve any of these problems. But what we have, to make our lives a little bit simpler, is we have a combined gas law. And it's a combined equation for all three of these laws. So if you had a problem that's dealing with Boyle's law, or Charles' law, or Gay-Lussac's law, you could just take the numbers and plug them into the combined gas law equation and get the right answer. So it's just a simpler way than to have to memorize each one separately. Over here is just a little key I made for you. The K means it's a constant value, so we're going to have constant values on each law, and then N is going to represent the number of moles. And what we can do right away is we can put an N on each one, because in all three laws, the number of moles doesn't change. It's a constant value. So we have moles is going to be constant in Boyle's law, Charles' law, and Gay-Lussac's law. And there's always going to be another constant variable in there. Let's start with Boyle's law. The second constant variable that we're going to have is going to be temperature. So constant number of moles, constant temperature. And then what's unique about Boyle's law is going to be volume and pressure have an inverse relationship. Okay, I always write it out this way. It just makes the most sense to me. If you increase the volume, the pressure is going to decrease, and vice versa. If you increase the pressure, the volume is going to decrease. And that's all it is. If we wanted to write the equation for Boyle's law, it would be the same thing we have up here, except for temperature, because temperature is constant. So well, why don't I write it out first? We could have pressure and volume of your initial amount, and then the pressure and volume of your ending amount. And that's the equation that you would use for Boyle's law. Okay, as you can see, we can just, if we memorize the combined gas law, and we know what our constants are, we know what's constant is number of moles and the temperature, and we know that volume and pressure have an inverse relationship, then we can just go ahead and cancel out. Let me get a box here, and we'll cover this up. Let's fill the box. Okay. So if you're using the combined gas law, you would just cover it up like that, and that's your equation. Okay. As you can see, it's the same thing that we have written out. Another way you could do it too is if you are given temperature. You could plug in temperature. I mean, as long as temperature is not changing, because it shouldn't. If it does, it's not Boyle's law. And you could plug in the temperatures. If it doesn't give you a temperature and you wanted to make up a temperature, pick any number you want. It doesn't matter. It's not going to affect your equation. But the simplest way is just to cover up what you're not using or what stays constant. And in this case, it's temperature. Okay, let's go to Charles' law. Okay, constant is your number of moles and your pressure. Let's get the right tool out again. Okay, number of moles and pressure, and then your temperature and your volume have a direct relationship. It's supposed to be an arrow pointing up. Okay. Direct relationship. So when temperature increases, volume increases. When volume increases, temperature increases. Volume decreases, temperature decreases. When temperature decreases, volume decreases. Okay, so let's look at what's constant here, the number of moles. Number of moles, we don't have to worry about it in our equation because we don't even put it in here, because it's always constant in all three laws. We can look at pressure next. If pressure is constant, we can take it out of our equation. So if we were to cross out pressure, it would leave us with volume over temperature equals volume over temperature. I'm going to get rid of what we crossed crossed out so we can use it for the next one. But so let's write that out. If we know our pressure is constant, we're going to have volume over temperature of our initial amount, and then our ending amount, same thing, volume over temperature. And that's the equation that we could use, or would use, I should say. Okay, going to Gay-Lussac's law, what's going to be constant is, of course, the number of moles, like we said, and then volume. Okay, and then temperature and pressure are going to have a direct relationship, just like we had above, only different variables here. Instead of temperature and volume, we have temperature and pressure. They have a direct relationship, so same thing. If temperature goes up, pressure goes up. Temperature goes down, pressure goes down, and vice versa. So we could go up to our equation. We look at what's constant, and what's constant is volume. So we could cross out volume. Why don't we go ahead and cross out volume? And what it would leave us with would be pressure over temperature. And then same thing for our ending amount. Okay, and that's about it. So the combined gas law is a very handy tool. You know, every student does it a little bit differently. If you, like I said, if you want to and you want to go through and learn each law separately, that's fine. There's nothing wrong with doing that. It's, you know, it's really doing the same thing. You have to memorize what's constant and what has a relationship with what anyway. So I'm not sure which way is going to really save you a lot of time. I think the combined gas law is a little quicker, works easier for me, but might not for everyone. So anyway, that's why we have the combined gas law. That's all it is. It's just a combination of these three laws, and that's about it. I'll make another video and I'll do some examples. Maybe I'll make this a two-part video, so this will be 1 of 2, and then I'll have a 2 of 2 and make some examples in there. Alrighty, that's all I got.